4分好，咁咧就今日咧就去32課，咁32課咧有2個部分嘅，第一個部分咧就係啲record 咗啦，咁啊係咪 record 咗啦？係，咁咧就前半段咧其實係回應翻第31課入邊一紮嘅啲 equations，咁我記咁多 equations 係做乜嘢咧？即係呢個係我哋都唔清楚，即係完全唔知道發生乜事嘅，咁所以咧呢一度咧係我哋都要諗一諗計啦，究竟點樣可以做得到？一啲即係真實嘅狀況，就係我哋做啲synthetic path 你點樣可以即係我假設我有一隻 compound 啦，咁啊一隻 compound A 咁樣啦，咁我點樣可以整到我哋心中想要嗰啲 compound 咧咁樣？咁有陣時唔係一步嘅，咁牽涉到有幾個步驟嘅。咁啊，你等一陣先，有啲 technical issues 啊，點解有啲？一橛睇唔到嘅，係咪下橛睇唔到啊？而家因為咁樣，好，好啲啦，睇到嘛？睇得晒係咪？咁咧就我哋咧就需要咧就做一啲叫做planning 嘅工作。嗱，首先我哋今日就係最主要講 planning 嘅工作。咁點 plan 咧 ？plan 一個 synthetic pathway。嗱 synthetic pathway 咧唔一定一步嘅，我可能係幾步。而考試佢哋咧每隔1-2年咧都會問可能係2個 step 啦。或者3個 step 嘅 synthesis 嘅 ，OK， 咁即係話咧，我由呢個 A 呢隻我被 given 嘅一個 A 嘅 compound 嚟，跟住咧佢就話俾你聽，我想整做 E 咁樣，但係原來咧你唔可能用一個 step 咧嚟做得到嘅，咁我咧原來要經過咧可能有幾個步驟，跟住最後至 E 嘅，咁嗰條問題咧就問你啦。究竟咧嗰啲嘅步驟，呢一集步驟其實係啲咩嚟嘅？而中間咧佢會牽涉到乜嘢嘅中間我哋有啲暫時性嘅嘅物質，咁暫時性物質咧叫咩咧？一啲叫 intermediate，OK，intermediate。So 我哋係由 reactant 開始，經過可能呢度有幾個 step 喺呢度 ，step 1、2、3、4，跟住咧可能係去到呢度，去到有一個 product。中間我要揾翻呢個 pathway 得唔得？咁呢個咧就係我哋想要嘅一個狀態啦。咁就係咪棒哥啊？棒哥又喺度好撳熄咗佢嗰個，撳熄咗佢，睇下未？係咪關佢事？係喎，好靜喎。你同都唔講嘢嘅，咁應該 OK 嘅。咁所以咧就咁所以咧就會。成個 pathway 咧就係最主要我哋學呢樣嘢得嘛？我哋成件事就咁啦。回顧翻呢個 pathway 啦，嗱呢個 map，咁呢個 map 咧其實同我之前俾緊你嗰個咧都有啲類似嘅，咁所以咧同學你係要揾得翻，咦之前嗰個 map 咧，你哋自己揾翻你自己 map 啦。咁你哋咧就要睇翻你哋嗰啲 map 入邊做翻啲補充啦。究竟咧，你係用翻書呢個啦，定係用翻我之前俾你嗰個啦，定係你要自己整嗰個 pathway，而令到你好清晰咁知道邊啲得，邊啲唔得，同埋每一個 step 入邊嘅所謂嘅我哋所講嘅 experimental conditions，OK？咁即係話我哋要寫得清清楚楚嘅。咩 experimental condition 啊？例如我哋可能要加熱啦 ，heat，可能係我要整 catalyst 啦，咁而個 catalyst 咧，我係要講清楚嘅。You have to specify the name of the catalyst and other experimental conditions, just like heat, any pressure, apply and etc. 咁呢個咧就係我哋所謂 experimental conditions。當然第一樣嘢我哋要有嗰隻係咩咧？由一隻 organic compound 另外一隻 organic compound，我仲會有一隻 reactant 㗎嘛，係咪？另外一隻 reactant，another reactant。Or you will say that a type of reagent, okay? What makes the transformation of one functional group or homologous series into another? So you have to get to know which station are there in a relative position in the whole map. So this is what I would like to remind all of you. So I do think that this one is we have some good points, right? Because you may further split, for example, you may further split the alcohol into primary and secondary alcohol. So by doing so, you may find that the primary alcohol can be oxidized to aldehyde, and further oxidation will occur to carboxylic acid. And how about secondary alcohol? They will just oxidize and they will stop at ketone. So what else? You may see the reduction. Reduction, you may need NaBH4 aqueous or using hydrogenation using a catalyst. And what else? And how about this one? Yeah. For this one, carboxylic acid back to primary alcohol, I will use lithium aluminum hydride dry ether followed by addition of acid. While this reagent can also be used when you are going to reduce aldehyde to primary alcohol or ketone back to secondary alcohol. So what's next? And this one, acid and alkaline hydrolysis, okay, and that you may know are the product reform. So you are going to take note of the different forms. Some of them will be in soft form, the other one will be in their molecular form. And similarly for acid and alkaline hydrolysis of amide. So you may find that, and acid and salt, and this one we have got a salt and then alkaline. Okay, so just give you a brief overview of what you have learned in chapter 31. So today we try to do something more complicated, is to think of this question mark. Okay, how can we transform from this substance to this substance? So you may find this one we have got carboxyl group. Okay, this is what the first step that you have to identify this carboxyl group as a starting point, and this will end at what? They will end at a halogens. We will call it haloalkane as the final product. So how about these? How about these? The benzene, that two benzene will not be reacted. So you need not consider anything about the transformation or any reactions involving benzene. Just focus on carboxyl group and haloalkane. How many steps are needed for you to transform from carboxyl group to haloalkane? And this is what we need to consider. Maybe some of you would have an idea, come up with mind carboxyl group and haloalkane. So for the first timer who are going to think of this, you may go back to this map, right? So you may circle the carboxylic acid, and also you may circle haloalkane, right? And try to see if you can go to 2 steps, right? So 2 steps. So what is the first step? Your turn. 有冇人答到啊？你同啊？哇！瞓咗覺添。哇！使唔使好似某啲大學咁要露樣嗰啲啊？即係開咗部機，跟住行開咗嗰啲咧，要起翻隊，因為唔計 attendance 嗰啲啊？喂，答嘢啊，大佬！劉仁正答 change to alcohol reduction. This is the first step. Yes, that's right. So this is the reactant, and this is the product, and they will go to here, right? This is one step. Can you see that? One step. Step 1, use reduction, and step 2, go to this way, right? And you are going to have this, or maybe simply you may see that sodium halide, console heating under reflux. If you don't want to use this, can you have alternative answers? 你同就 no 啦 ，so 啦啫，唉真係，哇！我同你個 time lag 咧唔止1秒真係。Okay, so it is called X, right? So if you are going to think of bromo, so that X is bromine. Okay, X is bromine. So you may use H and then Br. So the way to produce HBr, you are going to produce HBr in situ. Okay, in situ means on the site. So that's why I add sodium halide with console and heating under reflux. Okay, can you get my point? So this is a step 2. step 2 synthesis. But this is what you have to follow. Okay, so maybe for the first timer, just stick back to the map, and you can try to figure out what that is. Any other possible pathway? I can see Marcus. We just write down couple selected back to alcohol, to alkene, to haloalkane. Oh yes, that's right. But now there are so many steps, right? This is one step. What else? Now this one, what Marcus has been suggested. Go back to here, and then go to here, right? And then third step, that will be here. So we have got 3 steps for the red one. 何展鵬 what happened to 何展鵬 carboxylic primary alcohol, alkene, haloalkane. Oh yes, that's right. You can, but you of course, if you are having you are going to have a ride with your girlfriend, right? For example, you may extend the time to travel the train station and try to take as many stations as possible, right? Alcohol, go to alkene, go to alkane, and this whatever means, right? But try to take a look how many steps: 1, 2, 3, and 4. Now, so which one is the best way of synthesize the haloalkane? So we have got 2-step, 3-step, 4-step synthesis. Which one is better? Yeah, that's right. Yes, that's right. Somebody may argue, maybe Mr. Chin, you just take a. I can give you an analogy. It seems like in an MTR station, right? You are going to get into the train from certain station and go to the whatever route to another station. So it depends on you, right? However, while you take the 4 steps, right? You just like Emma, right? You have that experience before, right? If you want to take more steps, of course you need more time, right? But however, the least number of steps would be our concern. Do you know why? To see evaporators you are given. Not really the reason. Chemicals are expensive. Yes, that's right. Why? Side products, good. Efficiency, yes. Safe chemicals, yes, that's right. That's right. You may get all the point, because just imagine the case. While we talk about synthesis, for each step of a synthesis, do you know the per conversion efficiency? How many percentage would you think in organic chemical reactions? Do you know? 100%? No, no way. 80%? No. 50%? Also no. So 30%, most of the time, yes, less than 50, or even 10, even 20, and etc. So you may get some idea about your calculations. Suppose now I would like to think of the case just like making a 50% conversion efficiency for each step. I just want to simplify the whole case. For each step of the reaction, here gives 50% conversion efficiency for one step only. So what will happen if I have 2 arrows? That will be 50% times 50% conversion efficiency. Can you get my point? So the more the arrow, the more 50% will be times. So which will greatly decrease the overall conversion efficiency of the substance. Okay, so that's why not just like Marcus Lamb, you just write down those calculations and you can get what I mean. So what is the theory? What's the theory behind? You are going to think of the least steps of a synthesis, such as to minimize the chemical loss. Yes, so that's right. But at the same time, what you are targeting at, you want to get as much chemicals as possible. Okay, so for each step there will be loss. Second, if somebody you think you will think of the angle of safe chemicals, right? Safe reagents. Yes, that's right. We are talking about green chemistry. Now, this concept maybe new to you, right? So you may know it in Form 6. So green chemistry, we are going to consider the least steps. It is something related to energy. It's least step is you are trying to talk about money. Least step you are talking about environmental issues, because for each steps you may have need to deal with the solvent. Okay, so for some organic solvent is no good to the environment. So if you are going to have least step to have an organic solvent to extract the certain chemicals, of course you are going to do something good to the environment. Okay, so etc. So you may have some other consideration about green chemistry. I shall stop it here. So remember the rule of thumb is quite different from what you are thinking. Okay, you are not right that the case is not going like you are going to stay with your girlfriend, but indeed you are going to keep things as simple as possible. You are going to do the synthesis as quickly as possible, such as you are going to go into the product. So can you get a point? So you refer to this. There are so many steps for you to achieve. Okay, you are going to achieve. So you may find that you are going to choose these steps. That's it. So much for today's lecture. It's very easy. You're going to think of the steps as the smallest number of steps as possible. Questions? If not, your turn. Your target is to think of the two-step synthetic route to accomplish each of the following conversion. Give the reagents, reaction conditions, as well as structure of organic products. So I will give you the examples. You may refer to examples before. So you are expected to draw something like this. Okay, this is the target reactant. It will be the target product. So you may see it on the questions, right? You are going to have the reactant. Reactant, we have got a product, so you are going to fill the steps. So in between, you need to give the conditions, the reagents, as well as intermediate. You have got two steps, you have to think of two steps. So this is what you are going to fill in. Okay? Can you get a point? So that's why, do you know why I try to start over the new chapter? It's still the revision for the previous chapter. Your turn. ABC. A. Can you think of this? So how would you get approach to the problem? The first one, identify. Yes, that's a skeletal formula. If you write down this, of course, the formula should be in line with what you are going to have, right? First of all, was that it is ethane, and you will go to ethanol, right? From ethane to ethanol. So yes, you may get a pathway, right? But I would focus on the detailed way to write down the synthetic steps. How? From, can you see we are now showing the whiteboard. From, what is the original substance? We have got ethane. Is it ethane? To ethanol. So what is the first step? Cracking. Okay. Add chlorine under UV. The first step. Is it first step? Chlorine, UV, like this, okay? Or substitution. Yes, that's right. You're going to have a substitution. Also, what will we have? What will we have? The intermediate. Chloroethane, yes, that's right. CH3, CH2, Cl. So if you, but you may know that this step is a very poor synthetic pathway, but you have no choice. The only synthetic pathway from alkanes to haloalkanes, right? So you better add one adjective to here to make the synthesis to produce as much chemicals as possible. Corn? No, limited amount. Yes, that's right. Limited chlorine. By doing so, you may prevent the chance of having further substitution of chlorine, which means you are going to produce less dichloral trichloral, or even some others, right? It's not just direct substitution of the hydrogen. You can also substitute that hydrogen here. So you have got so many different products. So can you get my point? So this is the second step. So you have got this one to this one. You have got one-step synthesis. It's very easy. Why? Because you have got from coral compound and then go to alkanol. Alkanol. Yes, that's right. Or you want to write down O, or just hydroxide, right? Hydroxide. Yes, that's right. NaOH, AQ, heating under reverse. Yes, that's right. You are going to have a substitution again. So we have got two substitution reaction. The first one is by free radical substitution. The other one in university level, we will talk it as nucleophilic substitution. We call it SN. Nucleophilic substitution. So this is the free radical one. But it is just out of scope. If you don't understand, don't worry. Just think it as substitution, and that is fine. Okay. Oh, any more questions? Okay, so here comes the second one, right? Have you all copied it now? I will delete it. Okay. Oh, how about the second one? I would like to show you the second one. I better show it like this way. The second one, this one. Can you identify the change in the functional group? The change in functional group. So you may what you will get. Yes, we have got CC double bond here. We've got aldehyde, but finally we don't have any C double bond. But this time we have got COH. Delete the CC double bond. It's not just a deletion, but you are going to have a transformation from alkene back to what? Alkene here, right? So yeah. Good try, right? This one. Back to this. You are going to think of this, right? You are going to think of that as well. You have got two sympathetic pathway that you have to consider. So what will happen? Can you think of some possible pathway? Now let's try which one? Now you may see Marcus Lam, you're going to do hydrogenation, is it? 李彤 suggest it as a hydrogenation, right? Now, if you do hydrogenation, what will happen to the next intermediate? So what is an intermediate? What will be the intermediate? I save time. This time, intermediate. If you do hydrogenation, platinum, so what will happen? You do. You still need to draw a this one, and then how about this? All those change it to single bond, and how about aldehyde? What will happen to aldehyde if I do hydrogenation? You are going to have it as CH2OH. Agree? We have got 1, 2, 3, 3 carbon, 1, 2, 3, 3 carbon, and OH. Okay, so this is what I would like to address to all of you. I did not see any other. Oh, Marcus Lam will suggest aldehyde, but remember, once you use hydrogenation, the aldehyde will also be reduced to alkanol. So the product, the intermediate here is not product. The intermediate here is the primary alcohol. So what's the next step? It's easy, right? We've got primary alcohol back to carboxylic acid. You have to do what? Oxidation, right? So condition. heating under reflux. Can you get the point? Okay, so this is one of the possible pathway. Any other pathway? Is it what? How about Marcus 1? He suggested add oxidize the aldehyde to carboxylic acid and then do hydrogenation. Is it possible? Is it possible? Or does it work? Both work. 得唔得㗎? How many of you would think Marcus another suggestions possible? Please put up your hand. 一個、兩個、兩個，得嘅，係嘛？三個 ，yes， 四個。好，咁如果用翻Marcus 嗰個 ，so what will be the path? What will be the intermediate? This is our concern, right? So I just cross up the other. Trying to not to confuse all of you. And yeah, that's right. Okay, second pathway. Yeah, how will you write that here? First step, do the oxidation, right? You do the same thing, Cl2O7, 2 minus, exit, heating under reflux, okay, to form the exit. So if you do such, how about the CC double bond? Still here. Still here. So we have got COH, and I do hydrogenation. Hydrogenation, is it? Is it this one? Okay. Okay, so shall we take a look on the C part? What happens to the C part? We have got an ester, and then to alcohol. How will you tackle this problem? Alcohol. How about C part? Exit, turn back to alcohol. Maybe some of you may be puzzled, right? So because the alcohol, this one, the alcohol part is methanol, while for this one is ethanol. Okay, so what is the hidden message? This one, the alcohol, we've got 2 carbon, but it does not come from this part. Okay, it's not come from this part. Instead, you take a look on the acid, you have got 2 carbon. So 2 carbon and 2 carbon right there. So you may find such, right? So we have got the relationship. So never think of this one. You are going to locate that CC double bond. That 2 carbon is from here, right? But this one is ester and this one is alkanol. So what is the in between? It is exit. Can you get my point? So you need to figure out which is which first of all, and think of the intermediate, and you may bridge the gap by breaking down these two. And this is one of the possible way that you can reach the answers as quickly as possible. The first one, that's right, it is exit hydrolysis to form exit, and then exit back to alcohol is by reduction, right? It is hydrolysis. So how you are going to have 2-step lithium, aluminium hydride, dry ether, followed by addition of exit. So this is one. Okay? Questions? Now, if not, you may think of the last part. It is more complicated synthetic pathway. So the best way is to take a look at class practice. Because you have to think of a synthetic route. You have to think of as many steps as possible. It's not just 2 steps. So first of all, A part, you have got that 2 carbon, carbon double bond, and this one we have got 1, 2, 3, 4, 4 carbon, 1, 2, 3, 4. And this one is just ketone. Ketone, carbonyl group, but ketone is not LDR. How will you arrive at the answers? How many steps are there? Now, if you find that it is rather difficult to think, right? Maybe some of you just read the map and then trying to count the steps, right? This is one way. The other way that you may think of is to memorize the map by yourself, but you are going to have a concept of retrosynthesis. What does mean by retro? Retro means backward. So you have to think backward, such as to arrive at the answer. So what is mean by backward? You start from, this time I start from the product. What makes the product? Can you think of that one step? So by doing so, you may think of the intermediate before, just right before they come up with the product. So we have got ketone. What makes ketone? Of course, it is alcohol, right? So you are going to have an oxidation. Can you get my point? So alcohol, and so this is secondary alcohol. So you may get CH3, CH, okay, CO, and then you change it to what? CH is here, right? And then what's next is CH3, and make it as OH. Can you get the point? So we have got the OH. Can you think of this to this? Still difficult, right? Still difficult. But you may think of the one step before that may become closer to alkene. For example, this one. What can turn to this? So you may going to think of this, and then CH to the CH3, and then here it is something like halogens, right? Can you get the point? So because of that, you may bridge the remaining as a reagents as a condition. What is that? First of all, it's done by addition, right? By adding HBr. Mechanical through, okay, that hydrogen will be filled more, and the bromine is here is a major product. And then later on, from this to this, I add hydroxide AQ and heating other reflux. Can you get a point? Altogether, 3 steps. You get a point. Okay. And can you think of this one using the concept of retrosynthesis again? This one, what is that? Amide, not unsubstituted amide, and this one it is what is that? It is haloalkane. Halo. So how would you from this to this? Of course, from amide you can not think too much about this. You may have hydrolysis, right? Hydrolysis to form this CH2, and then we have got COH, right? But from this to this, you may have some more steps coming closer. Okay, because for the exit, you cannot think too much. The very most of you may think of, what will happen if I want to reduce it? Yeah, reduce it. CH2, CH2OH. Okay, and go back to this. You may think of this. Okay, so from this, how would you finish that pathway? Con HBr, and that's it. And then from this to this, what happened? You are going to make a reduction, and the problem is solved. Dry ether, and followed by the exit. Of course, you may think of some other pathway, and it seems that 3 steps it will be the minimum for both A and B. So before I end the lecture today, shall we share the concepts of the organic synthesis? First of all, rule number 1, you have to think of as least steps as possible. And second, for each step, you are going to find out what they list out the reagents needed, But most importantly, you have to think of the experimental conditions. Remember the temperature. If you don't know it, just eating under reflux or heat or distillation, etc. It depends on the conditions that you are going to have. Second, catalyst. If you have pressure, you have to indicate it as well, and you have to show the intermediate. And finally, you have got more than 2 step or 3 step or 4 step synthesis. For some instance, you have to think of the concept of retrosynthesis. Okay, I will just stop it here, and I will give you some more time to have a practice. And please refer to the chapter exercise for the information. Okay, I would like to end the lecture now. Questions? No. I will see you later. Bye bye.